So today we're going to go over FRQ, question FRQ 2009, question 6. And let me get there. There we go. So we are given, let me just get this up. We are given a standard f of x graph, f prime of x graph, which is of course the derivative of the f of x graph. We identify that it is decreasing, then increasing, then decreasing. And it's defined by the piecewise function, which is g of x and 5e negative x over 3 minus 3. And we learned that the graph is continuous, and also we see that the intercepts are negative 2 and negative 3 ln of 5 over 3, and that the g is a semicircle and f of 0 is 5. And this is useful later as it gives us the c value when we take our integral. Now for part A, it's asking for negative 4x through 4, find all values of x at which the graph has points of inflection. Justify your answer. And so we identified previously that the graph had 2 points of inflections. Since it was decreasing here, the slope was decreasing, then it was increasing at point 0, goes from decreasing to increasing, then it goes to decreasing at point 0. So this is negative 2, my bad, and this is 0. So your justification would be simple. You'd state that at point 0, the slope goes from decreasing to increasing, and then at point 0, the slope goes from increasing to decreasing. And that would be your f double prime graph. And for part B, we're going to go back to that later since it requires more written work, but it's basically asking find f of negative 4 and f of 4, which we can just find by taking the antiderivative of this and finding the area under the curves using these equations. And yeah, so we're moving on to, for now, part C, which is negative 4 to 4, 4, negative 4 to 4. Find the value of x which f has a maximum. And justify your answer. So in order to do this, we have to identify the top part is positive. Since we're looking at the f of x graph, we know that anything positive means it's a positive slope, which means that it's still going up. So it's continually going up from negative 4 to 3 ln 5 over 3. Then it changes from positive slope to negative slope at 0.3 ln 5 over 3. So therefore, 0.3 ln 5 over 3 in the f of x graph is an absolute maximum because the slope goes from positive to negative at that point. And that is your answer and justification for part 6A and 6C. And now we're moving on to part B. The car's pencil. Okay. Sorry. So for part 6B, we're trying to find f of negative 4 and f of 4. So we're starting with f of negative 4. And in order to do this, we have to recall that when you take integral of something, you'll get something something plus c. And in this case, c is given to you because it tells you the intercept. So you add c, 5, which is 5, to the integral of 0 to negative 4. Now the reason it's 0 to negative 4 is because your graph is branching out from point 0, and you only know the intercept for point 0, so you have to use from 0 to the other point where the graph is ending, which is, in this case, negative 4. And that seems to be a problem, because you can't take an integral from 0 to negative 4. It has to be from negative 4 to 0. So knowing our cheeky properties of integrals, we can convert that to negative 4 to 0 by adding a negative sign on the outside of the integral. And we do so here. And so, as we recall the graph, we remember that g of x is a semicircle. And so in visualizing it, it's like a semicircle boxed in a rectangle. I mean, around in a rectangle, yeah, boxed in a rectangle. And we're trying to find this shaded area. And we know that the length is 4 and the width is 2, and that the radius and yeah, so we know that the area of the rectangle is going to be 8. And we know that the area of the semicircle, since the radius is 2, is going to be 4 pi, and because it's a semicircle, divided by 2, so then it'd be 4 pi over 2 equals 2 pi. So it'd be 8 minus 2 pi is our area, g of x, and we do 5 minus, substituting that into our original equation, 5 minus that would equal 2 would, oh, after I distribute the negatives, and totally forget that, about the 2 pi, but I'll fix it. The hesitation, and there it is. And so our answer would be 2 pi minus 3. Now for f of 4, we see that it's the same situation where it's 5 plus the integral. It's a little bit unclear, but let me try to focus this. But it's the same thing as I'll read it to you. The function is 5e to the negative x over 3 minus 3, that beautiful 3, and dx. And so we have to take the integral. So it's 5 plus, and the integral of 5e to the negative x over 3, as we require the u substitution, we know that in order to make this antiderivative negative 1/3, you have to multiply by negative 3. So then, because the derivative of negative x over 3 is negative 1/3, you'd multiply by negative 3 and you get negative 15x, negative 15e to the negative x over 3 minus 3x over the 0 to negative 4. And after substituting those numbers in, you'll get 8 minus 15e to the negative x over 3. So thanks so much for watching.